Okay, Mandy, I think it's 11:01. If you're comfortable that we can start.
Yeah, I'm very comfortable that you can start. Maybe I should just introduce you to those who don't know you, and to thank you, Carl and Shireen, for agreeing to do this for the group. I know it's a bit late, but I think it's really important information. So about a week ago, we had a presentation from Professor Shaheen Matar, and one of the comments she made was that a lot of our staff had a training on PPE and virus and everything else, but there was very little training in South Africa on ventilation. Now, I know that the technical department have been working on ventilation since we first found out about this virus, and on scrubbers for the unit and on improving ventilation and opening windows. But I don't think everyone has really had a formal sort of presentation related to how to improve ventilation in your hospital. And in a very, very recent meeting about half an hour ago with Tiens Langenhoven, the discussion was that hospitals aren't really built for this kind of virus. So the ventilation changes that have to be made in hospitals are quite difficult because the HVAC systems are not built for this kind of ventilation, and probably something we should look at in the future. When you go around Africa, you find many of the hospitals actually do not have any ventilation whatsoever except for an open window, and that's the 90% of the ventilation in Africa. And we're quite fortunate in South Africa to have HVAC systems and a complicated healthcare building and support by technical services. So Jaco Russ is the, and I might get it wrong, the National Technical Manager and the National, he's also the Group Engineer for Netcare, works for Tiens Langenhoven, who's in charge of the entire technical department and all technical matters related and building related to hospitals. Shireen is the head of occupational health and safety for Netcare, and Carl works with Jaco in the technical department. I really don't know Carl's qualifications, so I apologize for that. And Jaco's got a very few slides, but he always has a lot to say. He's very knowledgeable, and I'd like you to take to be aware of what he's got to say and see if we can improve things in our own facilities and drop the amount of COVID positive staff and transmission we're having in our own facilities. Thank you, Jaco. I know you put you under pressure to present today for you and Shireen and Carl, but I really do appreciate it. Go ahead.
Thank you very much, Mandy, for the introduction. Yeah, so you are correct. We are all working in the property division under management of Tiens Langenhoven. And Kyle, my colleague, is in the asset management shared service department, driving and leading the line of sight and centralization of all our assets in the greater Netcare group. So that being said, hello everyone. I'm Jaco Russ. I'm the National Technical Manager for the group, and I would like to just give you some insights with the awareness that we are doing in Netcare at the moment, and how things are developing with regards to the management, elimination, and safety precautions that we are taking in all our functional areas within the healthcare facility. So without any further ado, I would like to quickly just go through the systems that we do have at the moment within Netcare in the HVAC environment or space. There's two major ventilation systems that's adopted throughout the world, and that's natural ventilation as well as mechanical ventilation, where you need external equipment to actually drive higher flow rates and air changes into a specific functional area. So I would like to just spend a little bit more time on each of these points, and then also if we cannot mitigate or eliminate the risk, the protection precautions that we also take within this environment with regards to managing of that, I will also discuss in this slide. So natural ventilation is all, as Mandy also stated, it's a very common way of mitigating the risk and also providing fresh air into any environment that you would like fresh air to be transmitted through. And it can be done by any openable windows or doors, so that you can get cross ventilation, which is this right-hand side section of this drawing. on the first top left corner, and then also by single side ventilation. So you have one openable window, and as the wind transmits over pressure differential over the window, you actually create some air movement within that room. Normally what we tend to do is in winter times, it's always quite difficult to manage the patient comfort in a patient room or area, because as soon as you open up the windows, you get the external temperatures inside the room as well. So the minimum prescribed opening of that window cannot be less than 15 millimeters or 5 centimeters. And that's just to make sure that the opening is big enough to actually give you the benefit of the pressurization and the air movement into that particular room. Now, I've also indicated a drawing on the bottom left corner of the slide with the type of airflow measures that you could look at. And as you can see in this document, there's multiple ways in how to conduct cross ventilation or single side ventilation through either one or two openings in a specific room. So typically what a hospital in South Africa consists of is a combination of fresh air and mechanical ventilation, which we would discuss just now. And it also gives you the benefit of the better of the two situations, depending on the type of area that you would work typically in. So that's the natural ventilation section. The mechanical ventilation is a little bit more intricate and a little bit more complex, because now you need to force a certain amount of fresh air into a particular space. And it's typically gauged against a quantification of people in a particular room. And the requirements that's spelled out in the Department of Health guideline for COVID control in the HVAC environment is 10 liters per second per patient. So if you have 3 or 4, so let's say 4 patients in a room, you will typically need 40 liters a second to satisfy the requirement with regards to fresh air discharge into the room. Now, the reason why they use this as a gauge, it's an easy calculation to do, as a rule of thumb out of a technical manager's point of view. And it also gives you the ability when your contractors are on site, or if you do have your technical facilities manager with testing equipment, you can actually calculate this if you really want to go into the finite detail of what each room does provide you with. You can both create this flow rate of 10 liters per second per person by 2 different ways. The one is by means of fresh air discharge. So you discharge fresh air into that particular room, and that is your flow rate for fresh air supplement. Or you could do it in extraction purposes. So you extract 10 liters a second in that room, and your makeup air either gets supplemented from a passage or from a fresh air system that's outside that particular room. That also talks into the positive and negative pressurization of that type of environment that you would like to operate at. If you have infection control, you would like to have a negative room, and typically you will actually get your 10 liters per second per person by means of extraction. In a burns or a neutropenic or hematology type setup or environment, it will be opposite around. You will extract in the passage and you will discharge fresh air at 10 liters per second per person into that room. So out of a legacy point of view, and that's why I briefly touched on the combination of the two systems. In the older pre-1990s, the ventilation regimes drastically changed from what we have today. And the fresh air component in certain instances is much less than the prescribed requirements that we need to satisfy in older facilities. So by combining the two ventilation systems, you can actually achieve 10 liters a second per patient, and better by actually having fresh air discharge, pressurizing that area, and also opening a window or cracking the window to actually provide you with either a balanced, neutral environment, or then a slightly overpressurization or underpressurization, depending on the type of design of that particular environment that you're operating at. Now this is typically where you have rooms on the outskirts of the building envelope, where you actually have windows and doors that you could open to give you this. You do have certain instances where a functional area or ward or ICU is situated more in the core of the building, and in an instance like that, you would then typically have better filtration systems and air scrubbers to alleviate this risk. So you still have circulation of air with a certain quantity of fresh air, but you cannot satisfy the 10 liters per second because it's in the core of the building. So the protection measures that you add over and above the openable windows to actually give you that component is filtration, which is a normal installation practice that we normally do in an environmental condition like that. And then also to increase the purity of the air is to actually install an air scrubber. We do have two distinct systems currently running in Netcare, and I've actually added the two pictures in for you. The unit on the left is a product from America, and then we have also developed and designed a Netcare air scrubber that's on the right-hand side. You'll see it works on the same principle as the one on the left. The one that we designed in Netcare just cleans the air at a much higher volume and floor area optimization. I think it's a 10-fold differential between the two. So these type of machines actually act as a filtration medium as well as a bacteria and virus elimination type method by means of UV light exposure. These units both does consist of primary, secondary, and HEPA filtration of a MERV 14 and 13 type criteria, and this is what we typically use to mitigate the risks with regards to optimal fresh air ventilation within the greater space, where we cannot introduce more mechanical ventilation or natural ventilation from outside the building envelope. Then the Department of Health also prescribed a good practice of when you do optimize and occupy certain spaces, that you leave the space unattended for at least 15 minutes from when you open windows or start your mechanical ventilation system. This just creates the air movement to take place, and that you can actually optimize your fresh air in that area before you occupy it fully. Now, in a healthcare facility, as we all know, that our fresh air and extraction systems cannot be switched off by a court of law. And that's why we have essential generators looking after the installation at the back end to ensure that we always have fresh air and extraction feeding into this area. So typically in a hospital environment, we would not have a 15-minute waiting period for interventions if it's already been adapted. Then lastly, I just would like to show you the controls to reduce the long-range airborne transmission criteria, and we are using this in our ventilation audits that we have done, and we will discuss that also in the next slide. When we evaluate the outdoor air ventilation system, if we have a ventilation system, we make sure that the dampers, as they call it, is fully open, or the air speed of the fan is is opened up fully so that you have 100% discharge of fresh air into the area. And also we open up close the recirculation ducting if we don't have HEPA filtration and UV contact in our HVAC system. If we do not have a HVAC system that's fully compliant, then we open the window, we crack the window as discussed a little bit earlier. What we also then do is, like I explained, we increase the filter efficiency. If we have an HVAC system, we always ensure that we install the right filtration for the right environment, as you have different environments that calls for different filtration systems right up to MERV 14 requirements. And then if we cannot sustain filter efficiencies, fresh air or natural air from outside, then we supplement with portable air cleaners or then the scrubbers as discussed above this slide. So that is what we are doing in Netcare to ensure that we have optimal protection and safety precautions taken in our healthcare fraternity that we are operating in. What we have also done as a matter of management, also stated by a court of law, that we need to do a 2-yearly hospital ventilation audit to each and every facility that we are operating at. And I just made a couple of notes here at the bottom to say that to ensure that we have 100% compliancy and surety that the ventilation audit is being conducted, we are making use of consulting engineers to actually assess the entire installation of the hospital's ventilation and extraction systems. The outcome of the assessment is then put forth in a report structure, which we are managing from a central point of view. And the outcome assessment is split into 2 major entities. It's maintenance-related requirements that we need to look at. It might be a damper that's faulty because of the test that they conducted. There might have been a damper that failed because everything is mechanically orientated. And then also there might be a CapEx initiative that we need to embark on to increase the airflow requirements or the air change requirements in a particular space, if there was any changes that was required when they conducted the tests. So from a central point of view and the AMS side of things, we are all monitoring this quite vigorously. We have received a lot of CapEx this year to actually do a lot of these initiatives on the HVAC type of modifications to ensure that we comply fully to the latest codes in our older facilities. And the maintenance requirements is being done quite vigorously as well from a ventilation and extraction point of view. So once we have all conducted this, there is only one tool that would typically assist us in proving this from a facilities management point of view on site as a snapshot of what our systems are doing and capable in doing, and that is by means of carbon dioxide monitoring. So you have a special handheld device that we are using at the moment, and you can also buy equipment that you can fix against the wall, install inducting units of ventilation, mechanical ventilation systems to actually provide you with carbon dioxide quantification that's measured in parts per million. And that is the final check to make sure that between the design, the reviews and the audits, the maintainability and the preventative maintenance that's taking place, and also the execution of that is constantly tracked and monitored, carbon dioxide sensing is your answer. So Shireen is going to talk into the carbon dioxide monitoring and tracking in more depth, what we are busy doing at the moment. And we've started with this process Friday last week, and we piloted the the line of sight monitoring and controlling of this environment, and that it's a collective approach from a technical point of view and also from a HSS point of view, so that we work together to ensure that we protect our patients, our staff, and our public to the absolute highest level that we possibly can control them at. Shireen, I'm going to steal one of your slides, and then I'll give it over to you if it's okay with you. I just want to quickly explain the way the machine works and how the machine looked like, so that everyone understand what this machine does, and then you can talk into the control portion of it if it's okay.
It's okay, thank you, Jaco.
Thank you very much, Shireen. So yeah, so this is the machine that we are busy using in the group. You will see the top right corner of this red machine that you see here in the middle of the presentation. The carbon dioxide sensor is located in there, as well as a temperature probe and a relative humidity probe. And that you can actually see the actual display on the far left hand-drawn sketch. You'll see the top section is your carbon dioxide level, and in this case it's 512. Your relative humidity in that particular area is 60.5%, and the room temperature is 25.8 degrees centigrade. So there we have a special technical bulletin and also a document that Carl Reddy would talk into just now. We actually have a whole way of maintaining and operating this device, as you can see on the right-hand side. I just want to give the opportunity to Tiens Langenhoff, and I see his hand is up to comment. Hello, Tiens.
Jaco, Tiens won't be able to unmute. Let me just find him and then I'll unmute him.
Okay,
Tiens,
thank you.
Just hang on 1 second. I don't know why I can't unmute him now. Oh, there you go. Ask to unmute. Tiens,
Yeah.
can you unmute? Tiens, you can go ahead. Jaco, he is unmuted, so I'm not sure what's happening. Okay.
Okay. Yeah. Let's. I'll carry on. I don't want to take more time from the other two presenters. So this device has been procured most probably 6 or 7 or 8 months ago by Netcare centrally, and it has been distributed to each and every technical manager and hospital regional office, as well as both our shared services department and head office. We have also created, with the help of our shared services department or AMSS, a schedule that's being notifying the technical manager on a monthly basis to take routine measurements on a sample basis, because you have a centralized mechanical ventilation system taking place. So if you measure in 10% of your rooms or functional areas, any of those areas to be below the required carbon dioxide level, CO2 level, it's immediately a notice that there's something wrong with the central system. Then just a carbon dioxide measurement allowance that we are doing at the moment, and I think there's a lot of webinars and data pertaining to how to measure carbon dioxide. Is the fact that we are doing a sample rate in the functional areas of 10%. Then the requirements is that the carbon dioxide level cannot be more than 400 parts per million above the outdoor carbon dioxide level. So Shireen would now talk into that when she presents the centralization and the upload of that. So typically take a measurement from the outdoor condition. Let's say it's 400, because that is what the ASHRAE is prescribing. and we go measure inside the room and we get 650 as an example, we know that there's a 250 carbon dioxide parts per million in the air measured that's generated by the people in the room, which is then allowable tolerance because you have to be 400 above the set average of 400 as prescribed as an average by ASHRAE. So a lot of people talk into the 800 ppms. It cannot exceed that, and that's because they assume a 400 carbon dioxide level as an outdoor condition. With what we are doing now and what Shireen will present now is we will take a measurement from outdoor. Typically at Olivedale, we did the test, and the carbon dioxide level at Olivedale, just on the outside of the main entrance of the building, the level was, I think, 247 parts per million, and then we just add 400 to actually get the absolute maximum allowable carbon dioxide buildup in any functional area. Then I already discussed that this is a combined effort between technical and OHS representatives. And the reason for that is that we have a coherent review from both the safety representatives as well as technical, because both the departments must always ensure that we protect our people inside the building, regardless of what they are doing there. Then the last item here is the capturing of this information on safe site to have line of sight, and also the tracking and line of sight that we want to try and enable hospital managers, regional managers, national managers to actually see what the overall condition is of the ventilation and fresh air system in our group at this given moment in time. So that being said, I think I would like to hand this over to Shireen. I will keep the steering wheel intact. As Shireen asked me, I will move the slides on as required. Shireen, the floor is yours. Hello, Shireen.
Thank you, Jaco. Sorry, I was on mute. I couldn't unmute myself. So can you hear me now?
Yes, we can.
Thank you. You can just move the slide for me. Thank you, everyone. So I just made a copy of the mobile app guideline that I created for you to teach you how to use the SafeSite mobile app. So first of all, what you're going to need if you're going to do CO2 monitoring is you need a mobile device. So for most of the OHS practitioners and technical managers, they've downloaded the mobile application from SafeSite on their phones. But we also have roaming mobile devices like iPads, which we use for hand hygiene monitoring or for Aircon, etc. So you can use any of those iPads on which we've already installed the SafeSite app. So when you log on to SafeSite for the first time, you obviously need to just use your clock number as your username and password, and then it will ask you to change it after that. Most of you would have done it already. So when you go onto the mobile application and you've logged in, you will see that the landing page will be this on the slide on the right-hand side, the buttons with the 6 buttons on it. I want you to go and click on the button that says Forms. Once you've clicked on the button that says Forms, thank you, Jaco. Yeah, if you can just use your cursor. Thank you, I appreciate that. Once you've clicked on Forms, then it will open up all the different forms that's available to your site. So just in the conversation box, you type in carbon, and as you type in carbon, it will bring up the carbon dioxide monitoring tool. If you've got more than one facility linked to your name, just make sure that you choose the correct hospital, because there is some of our hospitals where one technical manager or one OHS practitioner are looking after both sites, like for instance, Union and Clinton. So then just choose the correct one. You click on the green button that says Complete Form. Jaco, you can go to next slide. Okay, then on the left-hand side, step 3 is it's going to ask you in question 1 just to tell us what is the outside reading. So Jaco has said when the technical managers do it, they can do the outside reading on the top of the roof. I don't want occupational health practitioners to go to the top of the roof, so just go to any outside area where there's not a lot of cars or traffic, and then take a measurement there with your handheld CO2 monitoring device. You enter the data there. Then the next question is going to ask you, where are you monitoring this? So you go to the ICU or the high care or billings or wherever you're going to go and do the specific measurement. Just enter the area where you're at. And remember, don't just tell me that it's ICU. Please tell me where in ICU are you measuring it. Is it at the nurse's station? Is it in a specific room, like a 4-bedded room, etc.? Then you just enter the value as well. On the right-hand side there, which was your reading. Obviously, then you just need to use your mathematical skills to go and see the outside reading plus the indoor reading, how much does it get to, and make sure that the indoor reading is not above 400 ppms of what is on the outside reading. So if the outside reading was 200 and the inside reading is 400, and 50, then you know you're above. But if it's 350, then you know you're below, if that makes any sense. If you're unsure, you're welcome to ask me again. Then the next 2 questions will be, is this reading within prescribed limits? If you said yes, nothing will happen. If it wasn't, then you have to say no, and then a task will be generated and sent to the technical manager as well as the OHS practitioner to inform them that there was a reading that was above the prescribed limits. Then we also want you to inform the unit manager or the HOD of a specific department when you did the specific measurements. It's already pre-populated on yes, but please make sure that you just inform them of the results, because then 1, they know that you've been doing monitoring, and 2, if there's a problem, they know that there's a health and safety risk in their department. So then the next question on the application will be to take a photo of the measurement. We did not make this field a required field, but it is obviously nice if you can prove what the reading was. So I just want you to click on the message that says select image, and then it will open up another pop-up where there's media and camera. Because we're not uploading files, I don't want you to use the media option. It won't work. I've programmed it so that you can take with the iPad or with your phone a photo of the reading there and then. You just click on the little camera button. As you can see on the right-hand side, it will show you the picture. If you're happy with the quality of your picture, you click on save. And then once you've saved, your form is completely done. You just now need to submit it. And once you've clicked on the submit button, then a pop-up will come up that says that the button is that your form has been successfully submitted. It's really quick and easy to use. We don't want to do the input via the computer because we want you to do it in the area where you are at. And I must also say, when we did it with Roland, it really doesn't take long. It's something that you can do quickly and that you can capture quickly there and then in the unit where you are at. Then the next step, if there was
Shireen, sorry, there's a hand up from Caroline Maslow. I don't know if you want to take it now or if you want to take it later.
We have created a questions and answer session just afterwards after the presentation of Kyle, so that we can take
so Caroline, we'll take your question afterwards. Leave your hand up, okay? All right, carry on. Sorry, Shireen.
No problem. So obviously, if there was a risk identified in a unit and you said no in the answer where it says, is it within the prescribed limits, then the technical manager and the OHS practitioner will both get a task via SafeSite. It will send a task to you on the email just to tell you that there's a risk and that corrective action must be implemented. You must then just click on the link there at the bottom, Jaco, where the arrow is. It says continue with task. You just click on the link. It automatically takes you to SafeSite. It will ask you for your username and password and a specific captcha. You just enter that and click on proceed, and then it will tell you that your task has successfully been completed. If you don't do the task within the prescribed time limit, then the system will continue to send you reminders. So the way that we've set it up, just for those of you who don't know how it works, Jaco and I agreed that for the technical managers, the task will be created so that they do it within 7 days. So that's 5 working days, in other words. And you will get a reminder 1 day before your due date. If you have not clicked on the link and you're overdue, then it will go on the non-conformance report and it will keep on sending you a mail every 3 days. For the occupational health practitioners, their task wording is slightly different. What we said is that there has been a risk identified. Please liaise with your technical services manager to make sure that corrective action has been implemented. And then we want the OHS practitioner to go and do a follow-up reading to see, after we've implemented corrective action, if the reading we're getting on the CO2 monitoring device is now correct. And then you also inform the facility manager of the results so that they also know what is the risk in the hospital and that it has been addressed. And I think, Jaco, you can just move to the next slide. You can then also go and pull reports on everything that was done for your facility. So if you now log in via your computer, you go to the button that says reports, then you go to form reports. Under form reports, you just type in carbon dioxide, then it will pop it up. You select the branches linked to your facility. Obviously, if you're only one hospital, you will only see one branch's report. And then it will open up on SafeSite the entire report of everything that was done. So any of the management team at the facility can go in at any time to go and look at the specific reports if you wanted to see if anything was done in your unit and what the readings were. And the 2 examples that I've put here on the page, the first one on the left in the middle is the individual report for a specific office or a specific area that was measured. You can just pull up that individual PDF report, and if you click on the download button that's highlighted in blue, you will see the picture of the actual reading that was taken. Or if you want a whole report of the entire facility, then you just go and look at the Excel spreadsheet like the picture in the presentation below, and you can see some of our hospitals already started capturing some of this information. So there's Montana, Femina, Ferncrest, Jacaranda. So there will also be a group overview of what's going on in our facilities. And if you wanted to specifically see what was the picture reading, you can see there's a column that says download, and you just click on the download and it will open up the picture for you. And Jaco, I think that is it from my side, from a SafeSite perspective.
Yeah, no, definitely. And yeah, so I really do think there's benefit, as you guys can all see in the bottom picture here. You have now true line of sight, and you can actually see what the outdoor conditions does. And you can also see what the carbon dioxide would typically do in a functional area that's stated here. So the nice thing is with this report that you pull from a hospital, regional or national perspective, you can actually sort by the carbon dioxide levels, or by within or without the limits. And you can actually work off that list to ensure that you have line of sight, so that this can be remediated between the notification date or the measurement date and the rectification date. That's 7 days to either get contractors on site or make special requirements to get openable windows more open, or extra fans or scrubbers or the like. So thank you very much, Shireen. I really do appreciate that. Kyle, I think you are up next with your guideline tool. Are you ready to present? Hello, Kyle.
Hi. Yes. Thanks.
Hello, Kyle.
Yeah. Thank you, Jaco. So yeah, we thought we'll use the opportunity as well with this team to just talk about a lot has been mentioned, and one may say, what do I need, or how, if you didn't catch a certain point or two, how can we, what reference material do we have? And to answer that, there's two two things that are happening in parallel. One, Shireen's document or the presentation and the steps how to go about that are now will be distributed, and then we also take the same information and we put it into our COVID guideline. Yaku, if you could go to the next slide, please. This is a comprehensive document, so I wouldn't have the time to take you guys through every single point, but I thought I'll just talk about the contents page, just so that we understand what is available. Yaku, can you still hear me clearly?
Yes, I can hear you very well, Carl.
Okay, all right, no, perfect. Yeah, so basically this manual, it is quite a few topics. I'm just going to touch on a couple. So we've got roles and responsibilities. They're just basically speaking about the roles and responsibilities of the facility, and with a specific focus on the technical services side and what their role would be in maintaining or making sure that we are ready for surges, and also in turn keeping in with the theme of today, making sure that our ventilation is adequate. Oxygen pressure monitoring and consumption, I think we all know about that, and we've managed to get through a couple of surges using the principles, and this is just a refresher of the material that we already have. We've got plant monitoring, communication, critical contact list, which we all know about, and that basically will talk about the various tools that you have to go and look at your from your oxygen to your air, to your water, electricity. All of these things, they all are symbiotic to make sure that our facilities are running running optimally. Then we spoke about ventilation. This is basically what Shireen has spoken about. We touch on and unpack a little bit more around the CO2 measurements. You know, Yaku, you took me back to school. It's one of the first things that I learned. You know, human beings breathe in oxygen and expel carbon dioxide, and then that's pretty much the indicator of poor ventilation. If you have high CO2 readings, and hence now we have this the system in place to help us out. There to complement our ventilation, mobile air filtration units. That's what Yaku has just went into great detail discussing. So not much to talk about there. We also talk about ordering of oxygen cylinders, and making sure that we have adequate backup and we maintain that our stock levels to handle our surges. Fire safety and fire safety equipment, a very key piece of life-saving equipment that sits there. Our hydrants, hose reels, fire dampers, curtains, etc., etc. Making sure that we keep our eye on those, the maintenance of it, and the tests that are required, and the importance of testing those things, and how valuable they are. And we then also just touch on personal protective equipment, service provider management, and then what the document speaks about, some training requirements, and when do you go through this document. So a lot of times when we do these presentations, one of the first questions would be, you know, how do we get a hold of this material? And this is the answer to that question. Thank you, Yaku. Thank you, Mandy.
So,
that's it for me.
Yeah, thank you very much, Carl. I think that in very broad terms is the type of quantification that we are doing to protect our facility, not just on the ventilation subject, but overall building protection portfolio in this high level of surges that we have seen in the past.
So Yaku and Carl, would it be possible for you to email me this document so I can send it out to all hospitals if they haven't seen it before?
Yeah, we'll definitely do that, Mandy. We are with Carl, myself, and team. We are busy just revising the document again. Once the document is revised within the next couple of days, we will definitely share it with you so that you can distribute it to all relevant people that you need to.
Then if I can ask you a practical question, if you don't mind, in the Q&A session, before we go to Dr. Caroline Maslow. It's been a very good presentation, but practically, I am in my hospital now. what do you want me to do right now, today, before everyone goes away, to improve the ventilation in my hospital, besides measuring the CO2 and everything, some practical hints of offices, tea rooms, and areas that I can improve either the cross ventilation or the ventilation in my hospital. I know the first one is not to switch off the aircon. So that's the first one, maybe. Could you maybe answer that for me, please, Jaco?
100%. So yeah, Mandy, the best start would be not to switch off your ventilation, like you say. That would be a good start to keep it on. The best actual test is the nose test. So if you do move through your facility and you go into certain areas to do routine checks and meetings and so on, and you smell stale, stagnant air, it really doesn't, you can smell fresh air from stale air. That is the first identifier or indicator that you might have a ventilation problem. You get that staleness if you go on holiday for 2 or 3 weeks and you lock your house down, basically, as a good example. When you come back, you have that stale, strange smell of linen and whatever that's in the house. That's typically the first, easiest, practical way to actually assess if you have a ventilation or quantification of fresh air in that area as an indicator. The second point would be to actually ask technical to actually walk with the meter with you, and they place the meter down I think it's 2 to 3 minutes. You have to wait for the meter to stabilize with the air around the sensor unit, and based on that, then you will actually have a good understanding if you are over or under with regards to fresh air or air changes in that particular space or area. I hope that does answer your question, Mandy.
Yeah, just one other thing. Can I open a window if I have an air conditioner in the same ward?
Yes, so we must just be very cognizant with regards to the definition of a aircon unit. If you have a typical split unit, like we all know from a residential point of view, condenser outside with a ceiling wide away unit or a split unit type application, that doesn't give you physical fresh air. You have a HVAC system either by means of a diffuser or a disc valve grill that will push fresh air into that room. If you do have the relevant or the correct quantity of fresh air in that room, by opening up the window will, number one, neutralize the pressure that you have in the room in relationship to the hospital passage, number one. You will increase the fresh air component in that room, but you will definitely sacrifice the comfort portion, like I explained on my first slide. You will have some uncomfort or uncomfortable patients or people in that area because you're going to introduce the environmental temperatures. Let's say in midsummer in Durban, you will have a humidity of 80% and a temperature of 35 degrees, where your air conditioning system would have sustained it at 22 or 24 degrees.
Thank you, Jaco.
Yeah.
Thank you. There was a hand up from Caroline Maslow and then a hand up from Tiens Langenhoven, please. Dr. Maslow?
Yes, so good morning, everyone, and thank you for that very nice presentation. I just had some comments and question maybe. We discussed about, the CO2, of course, and I think it's a very good reflection. And when I tour, in all hospitals, 2 months ago, and we spoke about PP, I don't think there was a single hospital that didn't ask me if they could reopen, the tea rooms and all these rooms. So I think that you understood that outside, most of the CO2 comes from traffic and and industrial, walks and so on. But inside, it comes mostly from people living in the room. So maybe that's also, I was wondering if we could maybe test, in your rooms to see more or less, especially the small rooms where you don't have windows, so you cannot do any, you more or less cannot do much in these rooms. But to see, how long, because what's the kinetic of your CO2? So if you have a high level of CO2, and for example, you cannot, open really anything but the door, how long is it going to decrease? And maybe you could test, I don't know if it's doable, Jaco, to test some rooms to see I can have 2 people in that room, or I can have 3 people, or I cannot have more than 4 people, just to assess, once for all of the rooms, and maybe for these rooms, establish some rules. And the one I think, and that was my message at the time, the one where, where I think it's too, some tea rooms are kind of like closets, with very poor ventilation, especially in places like pharmacies and so on, maybe then ever add a ventilation system. We have devices like the one you showed. We have, smaller device for very small, places, and or just turn them into a storeroom and have a tea room elsewhere, because I think you all understood that we're going to be with COVID for a certain number of years, and we cannot have all these rooms being closed 6 months per year. It doesn't really make sense. So it's more about, about the kinetic, and maybe can we do some tests in some rooms to see how many people this room can accommodate at the same time, So
yeah, definitely, Dr. Maslow.
Yes,
definitely. I think definitely we have embarked with that already, and I think the sample that we've done, myself and Shireen, with the assistance of the technical manager Roland Vlok at Olivedale Hospital, we actually, Shireen did ask us to go into certain areas to actually do test it, where they converted a linen closet for a clinical staff member to do some admin work with a couple of shelves, or pharmacy store that they just modified slightly to assist the guys in that environment. And it was very clear, and Roland really answered it well. He said that by them doing the carbon dioxide measurement, they actually did find areas where they had excess of 1,000, 1,200 parts per million of carbon dioxide buildup in those type of rooms. And subsequential to that, what he has done is he implemented mechanical ventilation, because he couldn't open any windows. He had to install special ducting to actually enable that room to be functional and being safe. So that maybe is one part of your question that you did ask. And the second part of your question is, if you look at Christian Barnard, they already did the first measurement of the Billings department. You will actually see that the outdoor carbon dioxide level is 406 parts per million, due to the fact that they're right central in the capita of Cape Town. If you refer to a place like Universitas and Pilanomi, you'll actually see that the carbon dioxide levels are much less, because you don't have that high quantity of vehicles passing through that hospital. The same apply to a waterfall hospital, where it's outside the bigger capital.
I have a comment here, which is that because I did some tests myself, and if you look at if you do the test during the weekend, it will be half of that.
Correct.
Numbers. So we also have to make sure that we do the test during the week.
Definitely, and this tests will typically be done in the week, in working hours, and it will be most probably in the peak session of the morning traffic, midday traffic, most probably, while the guys are doing the tests. And also, because we are doing this test every month, the test is not conducted at the same time. So when we do see, last month we passed, but this month we didn't pass, by us understanding when it was uploaded, and we do have a date stamp on this, you could actually then track and trend if there's an actual problem with regards to fluctuation in environmental conditions. But we must also just remember, Caroline, it's a function of outdoor. So the higher the outdoor quantification, the higher the indoor would be, but it must not exceed 400. Your statement that you made with regards to more people in a particular room, let's say you have a billings department, and all of a sudden there's from 6 to 12 people that now increased in that small room. Within a month, we will pick it up and we will definitely flag it that there's a problem. And then we will start with our risk portfolio to actually eliminate, mitigate, or manage that particular risk.
Thank you very much. Jens, would you like to ask your question?
Yes, thank you, Mandy. Just want to check if you can hear me.
Yes, we can.
All right. Yeah, and good afternoon, everybody. I just want to, or good morning, to note what you asked earlier, Mandy, was what can a hospital do to improve ventilation? Now, in simple terms, I would like to refresh everybody's memory. Throughout our second and third surges, we made several presentations and we sent out technical bulletins on how to improve ventilation. And I want to just summarize those. Yes, one is open windows everywhere. Open windows. And it's not just in those areas, it's in your passages, it's in the common areas, because the more open doors and windows you have, the more draft there will be through the building. So that is absolutely crucial. Because I need to note that our hospitals, not just ours, all hospitals are not designed for infectious diseases like TB and COVID. It is designed for elective surgery. And therefore, it does not have the high level of mechanical ventilation that you would typically find in a TB hospital. But by increasing all of your windows, you are basically forcing ventilation through. And yes, that ventilation will have an impact on your comfort cooling, and you will have more complaints. There's no doubt about it. But unfortunately, in a surge scenario, you would have to deal with the complaints rather than dealing with the COVID in the air. Secondly, we said, do not recirculate air in your ICUs and high cares in the areas where you deal with COVID patients. Most of our air conditioning systems are based on an air recirculation principle, which is to do with ASHRAE standards, energy saving, and that's just how it is. But you can modify your air handling units to be full fresh air, which has been done in the second and third surge, and I'm reiterating this to the technical managers. Go check this, make sure that those recirculation dampers are closed and that it's full fresh air systems as far as it goes in these ICUs, high cares, EDs, and high risk areas. And yes, the consequence will definitely be more complaints, because if you put a full fresh air system through a recirculating air conditioning system, it cannot cool it down sufficiently because it's not designed for that. But unfortunately, again, we will have to deal with the complaints rather than the COVID. And so, to summarize it in those kind of things, open windows, eliminate recirculation, and change the system to be full fresh air where possible, because those are the things that will improve your ventilation. And the CO2 readings will tell you whether those systems that you've implemented has been successful or not. And if you do the CO2 readings regularly, it will cater for those times when the place is more busy, when there's more patients in it, less patients in it, because you have a various readings over more time. And it will tell you whether your interventions have been successful. Thank you very much, Mandy.
Thank you very much, Tiens. Yaku, there was a question about, are we going to be taught from Bonisile Radebe, are we going to be taught as to how to use the CO2 meter reading as occupational health practitioners? Clarity also on roles and responsibilities with regards the CO2 meter readings. Between you and Shireen. Thank you, Tiens.
So, Shireen, do you want to take this up?
Yeah, I can. I've just posted for the OHS practitioners on their group. Just go to your technical manager. He will teach you how to use the machine. It's really easy. There's an on button. You click on. You wait a few minutes for the monitor just to settle, because obviously the air needs to flow through the device. And then when you do a reading, it's just pressing the button and the reading comes up on the screen, but your technical manager can show you. And then, Yaku, I'm somewhere just going to read from the document that you and I agreed on. We said the roles and responsibilities. Technical department will do baseline assessment for facility to identify high-risk areas or areas of non-conformance. They will continue to do CO2 monitoring as prescribed by the SAP schedules. Oops, there my thing. And then I also said we'll continue to do maintenance of all HVAC and ventilation systems and take responsibility to rectify non-conformances. So the OHS department will independently monitor high-risk areas on a monthly basis based on the site-specific risks identified. This might be open plan offices, ICUs, high cares, or units where there are high occupancy levels with few air changes per hour, or where there's less than 10 liters of fresh air per person. Ideal is 15 liters per person, but minimum requirement 10 liters per person. We'll collaborate with technical to evaluate hazards and risks relating to inadequate ventilation and monitor compliance and resolution of non-conformances. Does that answer the question?
Thank you very much, Shireen. I think it does answer the question, but I think it's not about roles and responsibilities. I think it's all about, if you see a piece of paper, you pick it up. So maybe you develop a nice relationship with your occupational health and safety and technical, and sometimes the hospital manager and nurse manager may want to do it as well. Everybody should be involved in assessing their hospital to make sure it's safe and that we have good air change and CO2 levels. So there was
even a line manager, if they worry, they can call upon technical and say, come, please do it, and they can fill in the form.
I agree with you 100%. Yeah. Elizabeth, I think that answers your question. Then there was a question, CO2 level where our work is within limits. However, it bothers me that my own CO2 behind my mask is very high. If I can take that one, and if Caroline disagrees with me, she can answer. There was a study done by NOSH, the National Institute for Occupational Health and Safety, and the study was done in April 2021. And their answer to your particular question is, however, the increase in carbon dioxide concentrations did not breach the short-term 15-minute limits. Importantly, these levels were considerably lower than the NOSH limits during donning. So I think the only thing that will completely manage your CO2 levels is to wear a positive airway pressure device. So there is study done, and I've been in quite a restrictive environment for up to 8 to 12 hours. I think your body is able to cope with the CO2 levels. You sometimes, and I think these masks are made to eliminate CO2 and breathe in fresh air. The only problem comes when you start double masking, and you inhibit the mask's ability to eliminate CO2. Nobody made them. I think most people make masks with these considerations, and do look into that. And no mask would be passed for human consumption if it didn't meet the requirements of air intake, fresh air, and CO2 elimination. And what it's actually eliminating is particles, not really the air. Caroline, I don't know, or Shireen, I don't know if you want to comment on that as well.
Yeah, Mandy, I think our procurement team really goes and makes sure that the products that we buy has got the correct filtration efficiency that's required for a healthcare worker.
Absolutely. Caroline, anything else? All right, so this can one close the dampers to tea rooms without windows only? This allows for more fresh air. Jaco, Tiens?
So a combination of both would not make any difference to the fresh air component. To have mechanical fresh air and openable windows is more fresh air. It gives you more air changes in that particular area. And I wouldn't recommend closing any dampers, because the design for that system of fresh air was developed to ensure that there's a certain quantification of fresh air in that particular area. So I would just open up a window or two, or all of them. It will give you a benefit over and above what the mechanical ventilation is providing you.
So the question is, open the dampers. Is that correct?
Yeah, just a question from a point from my side, please. Every single area, and I wanted to also touch with what Caroline asked. Caroline asked if there couldn't be a guideline to say with one person, then 2 people, then 3 people in the size of the room. Unfortunately not, because every HVAC system, every ventilation system differs from the other. There's no absolute standard. And therefore it is very much a hands-on measurement, check what is the situation and make decisions for every single facility, every single room differently. There's no one rule fits everyone. And the same applies to these canteen areas or dining areas. Some facilities might have air handling units that you can convert to a full fresh air system. Others might have split units or cassette units or so on, which you can't, because they just recirculate the air. It depends. From every facility will be different, and therefore you need your technical manager to go out do the assessment. If you can change that system to a full fresh air, which means you close the damper that does the recirculation, in other words, it only pulls in fresh air, then you can do it. But combine that with opening of windows and check your CO2 levels to see whether that intervention works. Just keep in mind that if you do full fresh air systems where a recirculation unit existed, it will influence comfort. The comfort might not be as nice. You won't have the cooling and the heating capacity that you're used to, but it will give you a much safer air, and the fresh air component in the room will be higher.
Yeah.
Thank you very much, Tiens. So there are any other questions? There was one question: when are they going to get their meter? When shall we receive it from Nyoko Nyabane?
So all the meters have been dispatched to all the hospitals, and the technical staff is all in the possession of that meter. So everything is available right now as we are speaking. You just need to ask for it from technical.
So there's another hand up, or is it an old hand? I'm not sure. One hand is up. Can you
Eugene?
see whose hand is it? Eugene?
Maybe we must just...
Eugene Leshiba? They can all unmute. He is unmuted. Eugene?
Okay, his hand is down now, Mandy.
Oh, it was an old hand. He was playing with the hands. Okay.
His hand is back. Yes, Eugene.
Can we not hear you, Eugene? If we can't hear you, just type it. Eugene, would you like to type your question, because we can't hear you? Okay, we're going to move on from Eugene and see if he types his letter. He says, okay, I'll type. So just let's wait for him for 2 minutes. Is there anyone else who'd like to ask a question while we're still here, or say something? Nobody? Eugene, could you phone Yaku with your question, or even Tiens? Because I'm still waiting for your question, my friend.
The last comment from me, Mandy, while we're waiting there, I just want to say, open windows, open windows, open windows. You cannot open enough windows everywhere. Your corridors, your wards,
Eve,
because that will ensure a lot of fresh air. I just want to close with that.
Yeah.
All right, I think what we're going to do is we're going to get Eugene to phone Yaku. He can phone me, or he can phone Tiens, or he can phone Caroline Maslow, because I don't see the question coming up. And obviously he can't unmute. If there's nothing else from anyone else, except to say thank you very much to Yaku, to Shireen, and to Kyle for a very, very comprehensive presentation, and to the comments from Tiens and Caroline and all the interesting questions. And to wish you all well, and to hope and pray. There are 200 and something of you on the line. If we all have one thought about out damn COVID, then let's all think out damn COVID. And the only way we can do that is open windows. Thank you very much, guys. And also remember, in the taxi, when you're traveling, teach your staff, if you open the windows in a taxi, you wear your mask correctly, you keep a visor if you've got one, and you do hand hygiene, you also prevent yourself from being infected in a taxi. Thank you very much. Look after yourselves. Bye-bye.
Thanks, Mandy. Goodbye. Cheers, everyone.